Hello everyone. In this video, we will continue our discussion on the window functions in R. In part 1 of window functions in R, which will be linked in the description, we discussed what are window functions, and under the types we discussed ranking and ordering functions and offset functions. In this video, we'll talk about cumulative aggregates, rolling aggregates and recycled aggregates. In order to demonstrate the different functions, we create this data frame. So we have 3 students and their marks in 2 subjects. Let us first discuss the cumulative aggregates. So these functions perform cumulative operations within the given window of partition. Cumulative aggregate functions such as Cum_Sum, Cum_Min and Cum_Max are available in base R, whereas Cum_Mean, QAny and Cum_All are available in the dplyr package. So let's first discuss the cumulative sum. The cumulative sum function returns the cumulative sum of the elements of the input vector or column of a data frame within a window partition. The syntax is Cum_Sum of x, where x is the input vector or column of a data frame. So let's demonstrate this. We have the input vector A. So the output is 4, the first data element. Then the second data element is 4 plus 5, that is 9. And then cumulatively the sum 4 plus 5 plus 6, 15. 4 plus 5 plus 6 plus 2, 17, and so on and so forth. Then we have the same cumulative sum function demonstrated on the data frame with the group by of subject. So we have cumulative sum in the first case is 78, in the second row it is 78 plus 86, in the third it is 78 plus 86 plus 90, which is 254, that is within this window partition. And similarly we'll have the cumulative sum for this window partition of maths. Next we have the Cum_Min function. The Cum_Min function returns the cumulative minimum of the elements of the input vector or column of data frame within the window partition. Syntax Cum_Min of x, where x is the input vector or column of a data frame. So let us demonstrate this. So in case of vector A, the output we have first 4, then between 4 and 5 the minimum is still 4, within 4, 5 and 6 the minimum is still 4, within 4, 5, 6 and 2 cumulatively now the minima is 2, and so on and so forth. In case of the vector B, the first case the output is -2, in the second case between -2 and 3 the minimum is still -2, between -2, 3 and 4 the minimum is still -2. Similarly, applying the same on the data frame, we have the first element output is 78, then 78 plus 86, the minima is still 78, then for 78, 86 and 90, the minima is still 78. For the window partition of maths, we have first is 92, then within 92 and 92, the minimum is still 92. Between 92, 92 and 79, now the minimum is 79. Very similar to the cumulative min, we have the cumulative max function with this very similar syntax. So in this case, so in the first output of the Cum_Max of A, we have first case is 2, then for 2 and 1 the maxima is 2, for 2, 1, 3 the maximum is 3, for 2, 1, 3 and 2 the max is still 3, so on and so forth. In this case, the first element is -1, so -1. Then between -1 and -3, the max is -1. Between -1, -3 and 3, the max is 3. Similarly, applying the same on the data frame. So we have 78 is the output of the first row. Then the max of 78 and 86 is 86. Then the max of 78, 86 and 90 is 90. So Cum_Sum, Cum_Max and Cum_Min are available in base R. Next, let's go to Cum_Mean. The Cum_Mean function returns the cumulative mean of the elements of the input vector or column of a data frame within the window partition. Syntax Cum_Mean of x, where x is the input vector or column of a data frame. So let's demonstrate this. So here we see 2, then 2 plus 1 by 2, 2 plus 1 plus 3 by 3, 2 plus 1 plus 3 plus 4 by 4, cumulatively, so on and so forth. Similarly, in this case, the first row is 78, then 78 plus 86 by 2, then 78 plus 86 plus 90 by 3, and similarly for the maths window partition. Next, we go to Cum_All. The Cum_All function checks whether the first data element satisfies a logical condition. If yes, then it returns true. Then it checks whether the first and the second element satisfies the logical condition. This occurs cumulatively till the last data element, synonymous to logical AND. Syntax cum all of x, where x is the input vector or column of a data frame. So let us demonstrate this. So 1 is less than 3, true. 1 and 2, both of them are less than 3, yes, so true. 1 and 2 and 3, all three of them are less than 3, no, so false. And then cumulatively it will be false. Similarly, applying this on the data frame, let's check. So 78 is less than 90, true. 78 and 86 both are less than 90, true. 78 and 86 and 90, all three of them are less than 90, no, so false. Next, coming to the QAny function. The QAny function checks whether the first data element satisfies a logical condition. If yes, then it returns true. Then it checks whether the first or the second element satisfies a logical condition. This occurs cumulatively till the last data element, synonymous to logical OR. Syntax QAny of x, where x is the input vector or column of a data frame. Let's demonstrate this using the vector A. So here, is 1 equal to 3? No, so false. Is 1 or 2, any of the two of these, equal to 3? No, so false. Is 1 or 2 or 3, any three of them equal to 3? Yes, so true. And then cumulatively it is true. So here in this case we have, is 78 equal to 90? No, so false. Is 78 or 86, any of these two, equal to 90? No, so false. Is 78, 86 or 90, any three of them equal to 90? Yes, so true. So we discussed the cum mean, cum all and QAny, which are under the cumulative aggregates that are under the dplyr package, that are available in the dplyr package. Next, coming to the fourth type of window function, that is rolling aggregates. The rolling aggregates are fast and efficient routines for rolling windowed operations. They are available in the RCPP roll package in R. Routines for the efficient computation of windowed mean, median, sum, product, minimum, maximum, standard deviation and variance are available in this package. Example, roll underscore mean, roll underscore median, roll underscore standard deviation, so on and so forth. For further details and breakdown of each of these functions, you can reference this link that I've shared in the notebook, and the link to the notebook will be available in the description of this video. In this video, we'll discuss the roll underscore mean. As you can see, there are a couple of different parameters within this function. So let's discuss those parameters. The first is x, which is the input numeric vector or numeric matrix. N is the window size. So what will be the size of the rolling window? Weights, a vector of length n, giving the weights of each element within a window. If null, we take unit weights of width n. By, calculate at every byth point rather than at every point. If it's 1, then it is calculated at every point. Fill, either an empty vector or a vector length 3, giving left, middle or right fills. We'll discuss this when we demonstrate the roll underscore mean function. Partial, the partial parameter is currently unimplemented within the RCPP roll package. Next is align. So how is the rolling window right? Normalize window weights such that they sum to n. And lastly, na.rm, that is how to handle missing values. So to demonstrate the roll underscore mean, let's create this data frame df1. Here we have 6 months over 2 quarters and the sales for each of the months. So our aim is to calculate the rolling average for 3 months. So we have the 3-month rolling average. So let's demonstrate this. So here in the first case, like we see that for January, we don't have data of the prior 2 months. And since it's a 3-month rolling window, if you look at the parameters, so roll underscore mean, the first is the sales column. That is the column on which the 3-month rolling average will be calculated. Then we have the value 3, which is the size of the rolling window. Since we are calculating a 3-month average, fill is 0. How so? So before 50,000, that is, there is no data available before Jan 22nd. So we have the output 0 since we cannot calculate. So fill is equal to 0. For the second month, we have 75. So before 75, we have no value in December. We have 50 and 75. So we cannot calculate the 3-month rolling average. So the output is still 0. For the case of March, we have 3 months prior data available ending March. So we have 50,000 plus 75,000 plus 46,000 divided by 3, that is 57. And then you have your rolling window, like 75,000 plus 46,000 plus 56,000 divided by 3, which is 59,000, and so on. So like you can see, we have the rolling 3-month average available to us, right? And the window that is we have in the first case, that is for 57K, we have this window of these 3 months, Jan, Feb, March. For April, the window is Feb, March, April. So it is rightward aligned, that is, it is moving towards the more recent months. So this is how we calculate the 3-month rolling average using the roll_mean under the RCPP roll package in R. Finally, let's discuss recycled aggregates. Recycled aggregates are based on the concept of vector recycling. Recycled aggregates are so named because the value of the aggregate is recycled to be the same length as the original vector. Recycled aggregates are useful when we want to find all records greater than the mean or less than the median. They can also be used in conjunction with mutate. So in this case, for this data frame that we created, we want to filter the data frame and we want to pick out values within this where the sales is greater than the mean of sales. So in this case, the mean of sales for all these months, whatever is the mean, so we'll basically get all the values. If we run this, we'll get all those months where the sales has been greater than the mean sales, right? Next, if we want to calculate the z-score and group it by quarter. So let's see. So this is in conjunction with mutate. So within Q1, we'll calculate the z-score as x of I minus mean divided by standard deviation. So the vector is recycled to generate the output. These vectors are recycled to generate the output and the z-score for each of the cases within the given window partition. So these are the 5 different types of window functions that we discussed in R. If you liked this video, then please like, share, comment, and subscribe to our channel. Thanks.